and we're going to continue this conversation, but first, we recently went to the Menlo Park TechShop to take a look at some of the 3D printers there. Let's go ahead and roll that tape. We recently went to the Menlo Park TechShop, which is a large, do-it-yourself workshop where members are always building interesting and unusual gadgets. The tech shop not only has a wide variety of woodworking and metalworking tools, but it also has a lot of electronic equipment, including 3D printers. 3D printers are somewhat similar to ordinary printers, except that instead of depositing tiny drops of ink on paper, they deposit tiny strands of melted plastic on a platform, building up layer upon layer to create solid three-dimensional objects. Chris Sasek, who teaches a course in 3D printing, gave us a demonstration. Chris, I understand you're going to give us a demonstration on this 3D printer here. Could you give me an idea of how it actually works?
Well, this is the MakerBot Replicator 2 3D printer. It is a printer that uses a PLA filament. This filament is PLA. It's made from corn, so it's actually biodegradable and food safe. And
it's plastic, right?
Yeah, it's a plastic. And it goes into this extruder where it gets very hot. It's going to get up to 230 degrees centigrade, and then it will come out through a 0.4 millimeter nozzle and run in a path that's designed by the computer, and we'll build our object up one layer at a time.
And what are you going to print for us today?
I was thinking to print a spiral staircase for you today.
Well, let's get started on this print. Can we?
Sure deal. Let's go.
Okay, let's do it.
All right, first thing I have to do is feed the printer. So I'm going to go and load it.
What are you loading?
I'm going to load the filament into the printer.
Okay.
So now that it's ready, load this in.
And that's all you do? You just stick it in that little hole and it probably clamps somehow?
So it was a spring-loaded plunger here that presses the material against a little drive wheel. The drive wheel has little kind of teeth on it. It grabs the filament and pulls it in. It gets hot in the extruder, like I said, 230 degrees centigrade, and then it starts to come out. And you can see it's already feeding out, so we're good. We can stop this now.
That's not part of the object yet, is it? No, that's just...
No, this is just letting us know that the machine is loaded and ready to go.
Okay, so we're looking at a spiral staircase, and now it's going to be cut into horizontal planes, and each plane will be sent separately?
Well, essentially, so we have our 3D model, and what it does is it slices it according to the resolution that we asked for. So I asked it to print it at 200 microns of resolution. So it's going to slice every 200 microns will be a new slice. So right now you can see the bed rising. All the information has been sent to the printer. The printer now will heat to its correct temperature, and then it will go to its home position and it will start printing.
3D printers are still very slow, although they're continually improving. Chris's 6-inch spiral staircase took about 3 hours to print. In addition to this desktop printer, the tech shop also has a larger 3D printer, a floor model called the ProJet, which unfortunately wasn't working the day we were there. Justin Leathers is in charge of the ProJet printer. Justin, what's your involvement with 3D printing at the tech shop?
I run the ProJet HD 3000 high-resolution printer for the company.
And what are the capabilities of that?
You have the ability to print larger prints or even smaller prints at higher resolution than you do on something, say, the MakerBot. But with that, it's much more expensive and it's much longer, so it takes more time to actually produce a part.
What sort of things do people actually use it for?
They print everything from test pieces for prototyping to small production runs. I've printed, one of our members uses it to print 96 tooth gears that are about less than a centimeter in diameter. So it has that kind of resolution capability.
Does it take any particular training to use a 3D printer? So here, for example, if someone wants to print on the machine, do you do it for them or do they operate the machine themselves?
For the ProJet, we print it for them just because it's a little too complex, and usually we can print more than one person's print at a time, so that way our build time cost goes down instead of increasing per print, because it could take 15 hours to print a part, and 10 hours to print another part. We can put them both on the same bed, and that way it takes 15 hours to print both parts.
Before you can do a 3D print, you have to define the object you're printing. One way to do that is by using a 3D graphic modeling program, such as the Inventor software from Autodesk. Using the Inventor software, you can quickly define objects of almost any size, shape, and complexity, and even add scaffolding under the overhanging parts so they don't collapse during the 3D printing process. And if you want to make a copy of a physical object that already exists, you can use a 3D scanner, which creates a precise 3D image of the object and stores the image on the computer. Chris Sasek demonstrates.
Well, we've got our Next Engine 3D scanner set up, and what we're going to do is we've got an object here. It's a little pipe section, and we're going to 3D scan this pipe, and we'd be able to then 3D print it and have a replica of that model. We could even take it into some software and manipulate it a little bit if we wanted to change the design, so to speak.
Okay, so let's see how that works. You just turn on the scanner and it scans?
Essentially, yeah, I've already set it up to scan, and when I hit the start button, it should start to scan. What's going to happen is it has some lasers, and the lasers will sweep across the object to get measurements, and then it has a couple of cameras, and the cameras will take pictures of the object, and it will rotate around. This scanner can scan up to 40,000 dots per inch, which is very high resolution. And then basically what it does is it takes all the images that we scan and it brings them here, interlaces them together, and then we have our model.
Finally, we discussed some of the TechShop's more unusual printed objects, including spheres within spheres. So we've seen the 3D printer in action, and now on this table we have a few objects that were printed by a 3D printer. Now, one thing here that really interests me is this right here, because this is a ball with a sort of latticework honeycomb design, but it's, let's see if we can get a good shot of that. It's a series of nested balls. Inside this ball, there's another one, and then a smaller one and a smaller one. I can't even tell how many are in here. It looks like it's at least 5 or 6. And this was all printed in a single print job, is that right?
Yes, this was printed on our higher resolution 3D printer, the HD ProJet 3000 from 3D Systems. And what they do with that printer is it uses a laser to actually cure the material in place. And so it's just built up layer by layer. So that's why you don't have any interference from one layer to the next, because they're just built up one layer at a time. And then it uses a wax between the acrylic layers so it can support the balls within each other and they don't actually touch. After we're done printing, we take this out, we dunk it in a little bath, wash all of the wax away, and then we're left with our model. Right now it's still a hobbyist thing. It's still few and far between, I think, for people who actually have them at home. And I also think there's a lot of people that have them that don't know what to do with them. But there's a lot of people out there just making cool things. And I teach the 3D printing classes here at TechShop. And the number one answer I get from people when I ask them, why are you here? And they say, because it's cool. And they just want to understand what it's about.
And that was our video from the Menlo Park TechShop. Clay, what has to be improved about 3D printers in order for them to become popular in the mass marketplace?
Well, there's going to be, excuse me, there's going to be a variety of things that different people will tell you. But I'll tell you the reliability of the extrude head mechanism. There's a lot of folks that are working on that, and they've made a lot of strides. These guys are actually really good at it.
You mean like preventing clogs and things
that's
like
right,
that?
Yeah. Preventing clogs, switching between different materials. I mean, this is PLA here. This, as you can see, this bed is not heated. And PLA, you don't have to have a heated bed. It's very comfortable as far as shrinkage of the material during the printing process.
What about the time it takes to print? It seems like it takes a really long time to print even a small object.
Speed is an issue, yeah.
What would it take to speed that up?
You know, I don't know if in the near future we're going to be able to speed the printing process, but one of the things that might really leverage the whole industry forward is that if the reliability of the print goes up and you can use the printer during off times. So if you can turn it on when you leave the shop or leave your facility and come back in the morning, and you can take advantage of all that downtime for print, in a way it's almost like it now takes none of your useful time. And so one of the big things to leverage now is to have the printer run unattended for 10 to 12 hours at a time and still be successful in its printing. That's probably the first thing that'll happen to make the prints come out quicker to us. You know, the second thing will be involved in the materials that we actually print with. How fast can they be extruded and cured and maintain their dimension?
Now, right now, many people think that it's only, you know, for hobbyists and things like that, but there are also some very serious users as well. In fact, we have a video. One of our correspondents recently went to Oak Ridge National Laboratory in Tennessee, where they're very big into 3D printers, and we're going to take a look at that video. So let's go ahead and roll that tape.